Hello students, I am Himanshi and today we will be learning chapter number 9 of class 10th, that is applications of trigonometry. So we have already done one session on this and today I will be extending this session to do some word problems. So first of all, quickly let us see some learning outcomes. We have recalled basic ratios of trigonometry. We visualized eye movements while observing an object, and we also saw some real life problems. So in this session I will be telling you about some more real life problems. So let us first recapitulate what we have done in first session. I told you about the introduction of this chapter, that why this chapter is important, why we are studying it, and its applications in real life. So let us quickly move on. So there are three important terms in this chapter: line of sight, angle of elevation and angle of depression. So we have already studied about them, but I would like you to recall them because these are the integral terms which will help us do real life word problems. So what is line of sight? Line drawn from the eye of an observer to the object. So that imaginary line is called line of sight when we are looking at an object, right? Then comes angle of elevation, angle formed by line of sight. See, when I am looking at an object that is a little higher, I am looking upwards, this angle with the horizontal is called angle of elevation. In similar way comes the angle of depression. When I am looking downwards, when I am bending my head, then the angle made with the horizontal is called angle of depression. Okay, so I hope you are ready to do some interesting word problems. So this is from NCERT exercise 9.1 question number 12. See, from the top of a 7-meter high building, the angle of elevation of the top of cable tower 60 degree. See, I would read this again. From the top of a 7-meter high building, the angle of elevation of the top of a cable tower is 60 degree. Okay, so you have been given angle of elevation. So while reading the question, we have to focus on the things which are given to us. So reading further, and the angle of depression of its foot is 45 degree. So angle of depression is also given. What we have to find is determine the height of the tower. So let us look at the figure now. See, this figure, what it is saying is 7-meter high building. So this I consider the building. This is 7-meter high. So these names I've given. Now they are saying angle of elevation. So clearly this, when you're going from C a little higher, this angle is angle of elevation. This angle is angle of depression. This is given to be 45 degree. Now they are saying that determine the height of the tower. See, this I consider to be the tower. But here you can see a little segment AE and EB. Why this segment? Because when you are looking at the figure, you have to analyze certain things just by looking. See, this DB is the horizontal, or you can say floor. This is the ground. These 2 points are on horizontal. This CD is perpendicular. This EB is perpendicular. Why? Because it is quite obvious when the building is standing, it is standing with 90 degree angle. So clearly CD and EB are parallel. Also, because they are parallel, CE will be equal to DB. So you have to remember that CE is equal to DB. Clearly, with the same logic, CD is equal to EB. That is why this has been mentioned as 7 meter and this I consider to be H. So this whole cable tower becomes AB, which is H plus 7 or 7 plus H, you can say anything. So let us start the solution. In triangle CDB, first of all, you have to recognize triangles in this chapter. Why? Because this chapter is applications of trigonometry. So here you will see triangles, as obviously we are talking about the relation of angles and side lengths. See, in CDB, this is the triangle. Here CD upon DB is equal to tan 45 degree, as we know that tan theta is perpendicular upon base. So tan 45 is equal to CD, which is given to be 7 meter, upon DB, which is unknown, and we are trying to find DB. Now before moving further, if you are having this question in your head that why ma'am, why we are looking at DB only, as we have to find H, why are we attacking this DB? See, the solution is quite simple. The answer to this, in this triangle, no length is given. We have to know one angle and at least one side length to know another side length. So if we find this side, we can easily find H also, and this CE is equal to DB as mentioned earlier. So DB from this equation is equal to 7 meter. Okay. Now as CE is equal to DB, this is also 7 meter, so I am writing 7 meter. Now in triangle AEC, so now we come to triangle AEC. So AE upon CE is equal to tan 60y, because in this triangle ACE or AEC as you might call it, AE is H and CE is 7 meter. As you know that DB is equal to CE. So here H upon 7 is equal to tan 60y, because this is perpendicular and this is base. So AE, that is H, upon CE, that is 7, is equal to what? You know tan 60 is root 3. We have already recalled trigonometric ratios. So you should remember that tan 60 is root 3. So we get H equal to 7 root 3 meter. Okay. But were you asked to tell the value of H? No. We were asked to tell the length of AB, which is the tower, and AB is equal to H plus 7. So AB is equal to H plus 7, which is equal to 7 root 3 plus 7. Okay. Why? Because H is equal to 7 root 3. So 7 root 3 plus 7 meter. So the answer is AB equal to 7 bracket open root 3 plus 1. Why? Because we have taken out common 7. So root 3 plus 1 meters. So the height of the cable tower is AB equal to 7 root 3 plus 1 meter. So I hope you understood this question. Let us move on to the next question. So this is question number 16 from exercise 9.1 itself. The angles of elevation of the top of a tower from 2 points at a distance of 4 meter and 9 meter from the same point. And what is that point? Base of the tower. And in straight line also. So we have to prove that the height of the tower is 6 meter if the angles of elevation are complementary. So let's look at the figure. See, these P and Q are the points on the ground which are at a distance of 4 meter and 9 meter from the base of the tower. And base of the tower is this B point, okay? And they are in the same straight line, which means this ground. These angles are complementary. See, do you know what are complementary angles? Two angles whose sum is 90 are called complementary. So if you take this angle to be theta, this angle is going to be 90 minus theta. So you can take any, like you can take alpha also. If this is alpha, this is 90 minus alpha. You can take vice versa also. If this is theta, then this is 90 minus theta. So that is up to you. What we have to do is, we need to prove that the height of the tower is 6 meter, which means we have to show that H is equal to 6 meter. So let us look at the solution. Let us assume that the height of the tower is H meter. You can take H, M, N, anything. Then we have PB equal to 4. We have QB equal to 9. We let that angle AQB is theta. So by using that these two angles are complementary, angle APB is 90 minus theta. Okay. So in triangle APB, see APB. In this triangle, h upon 90 minus h upon 4 is equal to tan of 90 minus theta. Why? Perpendicular upon base equal to tan theta. So AB upon PB will be equal to 90 minus theta, which means cot theta. Why? You have studied that tan and cot are complementary. So tan 90 minus theta is cot theta. So AB, that is h upon PB, which is 4, is equal to cot theta. Okay, which means h equal to 4 cot theta. Now you have to remember this value that we have found h equal to 4 cot theta, because we are going to use this further in our question. Now this triangle we have taken APB. Now we will take another triangle, that is AQB. Let us see. See, in triangle ABQ or AQB, you can call it by any name you want. AB upon QB equal to tan theta. AB is the perpendicular and QB or BQ is the base. So it is equal to tan theta. Now this is h. So h, and this is 9 QB. So putting the values, we get h upon 9 equal to tan theta, which gets us h equal to 9 tan theta. Now earlier we found out that h is equal to 4 cot theta, and here h is equal to 9 tan theta. But we need to find the value of h. So we are going to do something with the help of which we can eliminate this theta. So you know that tan theta into cot theta is 1. So what I do is multiply the two equations, that is h equal to cot theta, h equal to 4 cot theta, and h equal to 9 tan theta. If you multiply the LHS of these two equations, you get h into h. And if you multiply the RHS of these two equations, you get 4 cot theta into 9 tan theta. So you get h square, h into h square equal to 4 into 9, that is 36. Then cot theta into tan theta is 1. So h square is 36. So by taking square root, we get h equal to root 36, that is 6 meter. So h is equal to 6 meter. Here we will be ignoring minus 6. Why? Because h is a length and it can't be negative. So that is your answer. We had to find the length of AB, and that is 6 meters. So I hope you understood this question also. Let us move on to the next question. See, this is from your exemplar book, exemplar problem exercise 8.4. So the question is question number 14. From the top of a tower h meter high, there is a tower which is h meters high, the angles of depression of two objects. Here it is talking about two objects. So angle of depression is going to be different, which are in line with the foot of the tower. They are alpha and beta, and they are giving you that beta is greater than alpha. We have to find the distance. So let us see how the figure is. See, from the top of a tower, this is the tower, this is h meter high. The angles of depression of two objects which are in line. So these are the two objects, B and C. It is talking about angles of depression, which means when you look from A to these points. When you look from A to B, the angle is this, alpha. When you look from A to this point C, the angle is beta, and beta is greater than alpha. It is also given. We have to find the distance between two objects. That is, we need to find the distance between B and C, which means x. So I have assumed it to be x. So how we are going to proceed? See, first of all, you see there are two triangles, triangle ACD and triangle ABD. So I'm going to take this in triangle. I'm taking this triangle ACD. So in triangle ACD, perpendicular upon base is tan theta. So h upon y. H upon y is equal to tan of this angle, that is beta. Okay. This is one equation. We will use it. I am taking now triangle ABD. In triangle ABD, again h is the perpendicular and x plus y is the base. This is x, this is y. So the base BD is going to be x plus y. So h upon x plus y is equal to tan of this angle alpha. Now we need to find x. So if you cross multiply, you get h equal to y tan beta. So I am first of all cross multiplying in this equation. Then I will use the value of h from first equation, that is this one. So h is equal to x plus y into tan alpha, which means x into tan alpha plus y into tan alpha. Now h is equal to y tan beta also. So if you use the value of h from this equation and put it in this equation, we get y tan beta. See here, the y goes and gets multiplied with tan beta is equal to x tan alpha plus y tan alpha. But here I am taking this portion y tan alpha to the left hand side and subtracting. So I get y tan alpha. And in the right hand side we have x tan alpha. Now I need to find the value of x. So I divide the whole equation with tan alpha. Now here x into tan alpha, this becomes x equal to, the tan alpha goes to the denominator, y tan beta minus y tan alpha whole divided by tan alpha. I take common y, I get tan beta minus tan alpha, and in the denominator I have tan alpha. Now this is the value of x. We were asked to find x only, but here there is a small difference. We were given h in the question, so we have to give the answer in terms of those variables which are already given. The y was not given and we assumed it. So we need to replace the value of y, and I will use this equation for the same purpose. So x is equal to, the value of y from this equation is h upon tan beta, because y goes here with tan beta. So if h is equal to y tan beta, then we know, see, value of y becomes h upon tan beta. Okay, so you use this and put it here, h upon tan beta, and here we have tan beta minus tan alpha, and in denominator we have tan alpha. Now if you look at this, the value of x, you see that we have only alpha, beta and h in the answer, and alpha, beta and h were given in the question. So this is the final answer. So I hope you understood this. So let us summarize this session. The line of sight, as you already know, is the line drawn from the eye of an observer to the object viewed. So this imaginary line, as I've already told you, this is the line of sight. Then angle of elevation. Angle of elevation of an object is the angle formed by the line of sight with the horizontal. So it's this way. Always remember, if this is the eye, you're looking to an object which is here. This is the horizontal. This becomes angle of elevation. In the same way, the angle of depression of an object. Angle of depression of an object is the angle formed with the line of sight. Angle formed by the line of sight with the horizontal when it is below the horizontal. So the last point, see, we have done many questions, we have done many real life problems where we were given some height, length, distance or angles, and we needed to find different remaining components. So the height or length of an object or distance between two distant objects can be determined with the help of, yes, trigonometric ratios. So I hope that you understood this session. Thank you for watching.